rivet arrangement. Let we have a rivet here, one rivet here. I will take the simple problem first. It is to be designed for this load. Now this arrangement is symmetrical. The centroid of the system is somewhere here. This axis is x. This one is y. Let label this one is rivet number 1, rivet number 2. So for this one, to find out the centroid of the system, x bar equals to x1 plus x2 plus x3 plus x4 divided by the number of rivets, that equal to 4. Suppose this distance is 50 and this distance is 100. So what is the x coordinate of rivet 1 is 0. What is the x coordinate of rivet 2 is also 0. What is the x coordinate of rivet 3 is 50. What is the x coordinate of rivet 4 is also 50 divided by 4. So is x bar equals to 25. Calculate y bar also. What is y coordinate of rivet 1? 0. What is the y coordinate of rivet 2? 100. Coordinate of rivet 3? Again 100. What is the y coordinate of rivet 4? Is 0 divided by number of rivets. This one is 200, is 50. So your x coordinate is 25 and y coordinate is 25. So your first job is to locate centroid. So locate the centroid of the rivet system, assuming a point mass and by passing the axis through rivet 1, that is the lowest rivet on the left hand side. Now from this point, measure the distance between the line of action of the given force called as eccentricity E. The eccentricity is the distance between the line of action of force. If your line of action is vertical, you also draw your vertical. Shift here, then the line of action has been changed. So in mechanics, we can shift this force to this point. So if we shift this force to this point, the magnitude of the force will remain same, but the additional moment will be generated, and that additional moment will be equals to is F multiplied by this distance, and is this moment will be clockwise moment. So in this system we can remove this force, and this force will be shifted as it is here, plus one additional moment will be developed. So this force will be shifted to this point and will act in the same direction. Now the moment produced at this point, so in this one the moment produced will be clockwise, and this moment we write as F. F is given by F multiplied by P, and the force is downward. So your system is basically subjected. Basically it is a moment, or this one is perpendicular to the plane also, so we will treat this as torque. One plate is rotating with the other plate, so that will causing a torque. So it is better to describe this one as torque, a twisting moment. Divide this force equally into all the 4 rivets. This F is called as primary shear force. F is the primary shear force, and this F is equally divided in all the place. So we have F1 equals to F2 equals to F3 equals to F4 is same as F divided by number of rivets. So right now I have 4 rivets, and we prefer the same direction, so each of them will act vertically downward. So let's represent this force here. So in magnitude we will call this as F1, and this one is F3. We call this as F4. This one is F1. This one is F2. And we are keeping the same direction. Basically they are going to act in opposite direction. These are called as primary. Here, so rivet will cut in this plane, and this plane is circular section. So this force is parallel to the circular section. That is why it is called as primary shear force. Now to balance this torque, the procedure involved is join with G. like this. So join all the rivet centers with the given point, and on this rivet center, that is through this one, we have to show one force, either this one or either this one, which is perpendicular to the line of action. So this one is the shortest distance between this point, and we want this type of moment. So this moment was divided equally into 4 rivets, depending upon their length from this point. So let's call this length equal to L3. This one is a clockwise moment, so I will retain this step equals to F3 prime, and this I will cancel out, because this, if I use this one, the moment will be anti-clockwise, but if I use this one, my moment is clockwise. So cancel this. About this point, we want the moment at this point, this one equals to what? L4. So moment about this point should also be clockwise. So shall we go for this direction, or we should go for this direction? We should go for this direction. It's always perpendicular to this one. Now what about this one? We want a clockwise moment, so the direction is like this. And we also want clockwise, the direction is like this. So in this fashion we can finish up the 4 direction. Let's call this one is F4 double dash, F4 dash. This one is F1 dash. This one is F2 dash. Every time it is perpendicular. Each time, according to the definition of moment, force multiplied by perpendicular. So at every point we have 2 forces. One is primary, and then the second forces are F1, F2 dash, F3 dash, and F4 dash. These are called as secondary shear force. In this case, the secondary forces are proportional to the length from the center of rivets, that is F1 dash by L1 is same as F2 dash by L2 is same as F3 dash by L3 is same as F4 dash by L4. So all the forces are, the total moment is F into E. So total torque is F into E is equals to F1, this torque is what? What is this torque? Is F1 dash multiplied by this length equal to what? L1 plus this torque equals to what? F2 dash multiplied by corresponding length is L2. This torque is F3 dash multiplied by length L3 dash multiplied by L4. So what we have done actually, we have done 2 steps. Whatever the external force is there was equally shared between all this force. And similarly, this moment, is it distributed between the 4 rivets? So we are claiming the same thing. That is, this force is distributed between the 4 rivets, and this moment is distributed between the 4 rivets, then this arrangement is possible. That is, external torque is balanced and external force is also balanced. Now to solve this equation further, we can take the help of this one. Now if you substitute for this, so this is F into E, F dash L dash L1 will keep as it is. This F2 dash we can calculate from this. So F2 dash will be F1 dash multiplied by cross multiplied by L2 divided by L1. So and this L2 is as it is. Next is this F3 and first term. So what you get is F1 dash multiplied by L3 divided by L1 and is again multiplied by L3, and the story continues. Now in this case, F into E, I wish to take F1 dash by L1 common. So in this one, is this value is L1 square. Was already taken common. This L2 and this L2 is what? L2 square. L1 is already taken common. So this L3 and this L3 is L3 square. So plus L4 square. We know L1, L2, L3, L4, and we know the value of F into E. So we can very comfortably calculate F1 dash. Once we calculate F1 dash, then we can also calculate F2 dash, then F3 dash, and then F4 dash. So in this fashion we can calculate two forces, one is F1 and one is F2 dash for all the rivets. This is vector P bar and this is vector Q bar, and let's say the angle between them is the phi. Now we want to find out the resultant of these two. To find out resultant of these two, so this one is phi, so this angle is also phi. So this one is vector Q, this one is resultant R. So if you have two forces like this one, and if we know this angle, we can find out resultant of this force. So this resultant we are finding. So we will resolve this into two parts. One part is this and one part is this. Out of this part is Q cos of phi, and this one is Q sin of phi. The law of Pythagoras we can apply and we can find out this. So what is R square? This one is R square. This side is total is P plus Q cos phi. This one is Q sin phi. So this one equals to R square equal to P square plus 2 times PQ into cos phi plus Q square cos square phi plus Q square sin square phi. So this one is R square equal to P square plus twice PQ cos of phi plus Q square, because cos square phi and sin square phi is 1. So value of R is dependent on the value of P, the value of Q, and the angle between them. Now this value, if negative, then R will be lower value. Maximum value of this one is 1. In that case the R will be max value, and that is true also. If this vector and this vector, they are acting in the same direction, their resultant value will be maximum value. Is it fine? Now if they are perpendicular, so this value will be 0. In that case we have only P square plus R square. You are knowing this. One vector is this, other vector is this. Is the resultant value will be given by this vector plus this vector. If the two vectors are acting in opposite direction, then this value will be what? More than 90. In that case this is negative and your sum will be less. So what that? Instead of going for this result for finding for all four, you identify first that which forces has larger value of these two components. All component has same value of F1, F2, F3, F4. So don't show any interest on that one. Then you identify whether F1 dash is more, F2 dash is more, or F3 dash is more, or F4 more. Now for the present figure, they are symmetrically placed. So right now all these values are also same, because L1 is same as L2 is same as L3 and L4. So all these are 4 same. But if you observe the angle between these two forces, is this one angle is less than 90? If you observe the angle between these two, is it less than 90? And if you observe the angle between this one, is it an obtuse angle greater than? If it is greater than 90, this term is negative. It means that resultant of this and the resultant of this is always less than the resultant of these two. So how to identify the rivet which is heavily loaded? In that case, first step is that find the rivet which has a maximum value of secondary shear force. No comparison is required for primary because primary is equal value. Comparison only based on secondary shear force. If you observe that the secondary shear force is also same, then you take the decision based on value of phi. So this is the criteria is used. For this one is phi, this phi, and this phi is supposed to be the almost same value actually. But this phi, is it more than this phi? So you have to avoid this and you have to avoid this. So in this case, rivet number 3 and rivet number 4 are heavily loaded. So we can calculate the resultant value at reaction 3 using same equation as F3 square plus 2 times F3 dash into cos of, let's say, phi 3 plus F3 dash square. And in this case, because of cylindrical arrangement, F3 is same as F4 and F3 dash is also same as F4. So this value will be same as R4. It means that the rivet number 3 and the rivet number 4 are heavily loaded. Once we know the heavily loaded, then they will going to fail in shear. So value of R3 equals to, it's a case of single shear, so this is pi by 4 d square multiplied by tau. So from this we can find out the diameter of rivet. Now for this type of loading we have to check which one is going to fail or which rivet is heavily loaded. Now from observation of this figure, this one itself is the center of rivet system. So this external force P will be shown at this point, and this P will cause the moment along this one, and this moment will be equals to P into E. It's a clockwise moment. So this P is equally divided, and we will show one force here, we'll show one force here, and we'll show one force here. This is basically primary shear force. This value is P by 3. This value is also P by 3, and this value is also P by 3. Primary shear. So this P is equally divided between these three. The secondary force should be acted at 3, 2 and 1 in such a way that it will cause the moment above the center of rivet system in a clockwise direction. So if I take this as the center of system, then this force will act in a clockwise direction, and this value will call as F1 dash. Corresponding distance is L1, and that equals to what? A. No moment is caused at point 2 because this force will pass at this point, and is the force acting at this point will be acting this way, that equal to F2 dash, and the corresponding distance is L2 is same as A. So moment of F2 dash about the center of system is clockwise. So this total value will be equals to what? F into E. The forces, secondary forces, are acting at the equivalent distance. It means that F1 dash is same as F2 dash. So actually we don't have to do any calculation. If you apply the law of parallelogram of this force, is it a heavily loaded? And is it a least loaded? Because this and this, they are acting in opposite direction. So is this rivet is heavily loaded? So design is based on the rivet number 3. Can we find out F2 dash? Yes, we can find out F2 dash. That equal to what? P multiplied by E F1 divided by L1 multiplied by L1 square plus L2 square. We have just done this. This one is P multiplied by E F1, L1 is A, and this one is A square plus A square is 2A square. So F1 equals to P into E divided by 2 divided by 2A. So you can just put up this value. So this one is heavily loaded. So design is based on this value equal to pi by 4 into d square multiplied by tau. So the order of shear stress will be tau 3 is more than tau 2 is more than tau 1. So just by observation your center is somewhere here. So center is somewhere here. So this distance is 40-40 and this distance is 30-30. This, the force 10 kN is equally divided in all 4 rivets. So 2.5, 2.5 at all places. This one is primary shear force 2.5. To find out the value of secondary shear force, we'll join this with this center. And this radial distance is same for all of them. For this one, we have equals to 40. This distance equals to 30. So this distance equals to 40 square plus 30 square, that equal to 50. So it means that L1 is same as L2, is same as L3, is same as L4 equals to 50. Now this is their length are same, their forces is also same because force is proportional to length. So F1 dash, F2 dash, F3 dash equals to F4 dash. All secondary forces are same. How to calculate the forces? We have a formula. External force P multiplied by E must equals to F1 dash by L1 into bracket L1 square plus L2 square plus L3 square plus L4 square is same as 4 times L1 square. So this answer come out to be 5. So all these forces are equals to 5 kilonewton. To show the direction of this force, you have to first connect your rivet center to G, draw perpendicular in this direction such that the rotation of this force will develop the clockwise moment, because this P also will produce clockwise moment. So once you decided one direction, continue this. Every time this is perpendicular to length. So every time is perpendicular to length. So we know all these forces. This one is F2 dash, this one is F3. Now we want to find out this angle that we are calling as angle phi. This angle that we are calling as angle phi. We will only consider these two processes, that is these two rivets, because their angle is less than 90. Now this rivet will never fail because angle is more than 90, and this rivet will never fail either this angle or that angle, because in both cases it is greater than 90. So only we will go for either 2 or either 3, but both are symmetrically placed, so this phi and this phi is also same. So to find out that value of phi, I will consider here a right angle triangle like this. Here this line and this green line make an angle of 90, so this one is 90 minus phi. This one is 90 minus phi, so this angle must equals to phi. So this phi is, this length is 40, this length is 40, this length is 40, and this height equal to what? 30. So this height from here to here is 30. So we can very well find out tan phi. So tan phi is 30 divided by 40. So that equals to 36.86. Law of parallelogram of forces. Resultant force at R2 is same as R3. F2 square plus F2 dash square plus 2 times F2 into F2 dash into cos theta, that is cos phi. So put for F2 equals to 2.5. F2 dash we are just calculated equal to 5, and angle phi equals to 36.86. Suppose we are given tau equals to 90 megapascal. So can we calculate the diameter of rivet? So that will be equals to R2 equals to pi by 4 into d square multiplied by tau, that is 90. From this we can find out diameter of rivet.